Right, let's start by interpreting the data given and also the diagram here. We know a couple of things. We know that first of all, BC is equal to AD minus AM minus ND. They'll probably come in handy later. And AD is actually 10. AM is X and ND of course is X too. So minus X. So you have 10 minus 2X. And this is one thing. And also we know that from the triangle, the right angle triangle, this BM and A here, this is the length of this is X, this is Y, and so MB square is equal to Y square minus X square. In other words, MB is equal to square root of Y square minus X square. Now this probably will be useful later, we're not too sure. Okay, so I think we can start now by tackle this part A and show that the area of trapezium is given by this. About, of course, the area of trapezium ABCD is half times height MB, I mean, and times the sum of the two lengths. So we have half Y square minus X square, and AD is 10. BC is right here is 10 minus 2X, and so in other words we'll get 10 minus X Y square minus X square in CM squared. This is shown. Right, now moving on to right here. Now find X in terms of Y. Now what can we use? We do know this. We do know that the AB plus BC plus CD is equivalent to 20 cm. This is the condition given earlier. Well, AB is actually Y, and BC is in fact 10 minus 2X, and CD is also Y, is 20. If you rearrange this, you get 10 minus 2X, or plus rather, and so we have Y equivalent to 5 plus X. Okay, so this is a relationship that we obtain. Now next, we know that the gutter has a fixed length, as you can see here, K, and so the volume of the gutter is the area of the cross section times the length. So the area volume is equivalent to area of ABCD times length times K. So area of the ABCD we have shown earlier in part A is actually 10 minus X Y square minus X square, the whole thing times K, and so this is K 10 minus X, but you do realize that Y is in fact 5 plus X as given in equation 1 here. So this is 5 plus X square minus X square, and our aim is that we want to show that we can get to here. Okay, so K is 10 minus X. Expanding this carefully, in this you have plus X square minus X square, and this will cancel each other, these two terms. You have this. And so we have a Vx. If we square both sides now, so we have Vx square equal to K square 10 minus X square, and there's no more vertical, and this is shown. Of course, do not forget to add the unit cm cube. So we have shown this. And so okay, now there's one more part for us to look into. That is this. Hence, find algebraically the value of x, which will minimize or maximize rather the volume water. And we got this in part C. And so what we're going to do is going to differentiate this with respect to x. We want to find the values of x which minimize or rather maximize the volume. So the k is actually just a constant, so we keep that. But this part, this is a product of two functions. So then let u be 10 minus x squared. So u du dx is actually negative 2 10 minus x, right? And the vx or v is 25 plus 10x, and so the dv dx is 10. So we can use a product rule here. U dv dx, so we're gonna be u dv dx times 10 plus v du dx 25 plus 10x times negative 2 10 minus x, and there's a common factor of 2 and 10 minus x, as you can see here. So now I can factor this 2 10 minus x, and what I have here is then 5 10 minus x for the first term, and right here I have the negative actually 25 plus 10x, and there's no k. So let's simplify further. Right here, so this is 50 minus 5x 25. Okay, and let's be careful with your work. A square and you check this. This is in fact going to be 25 and minus 15x. Okay, and we set this be 0. So from here we can see that the critical values or critical points being x equals to 10, and also x here, x equals to, set this 0, x equals to 5 over 3. Okay, however, understand that we can't take x equals to 10 because this is the cross section of the gutter. This is x. If this were to be 10, this would be we can't even form the gutter because the length here must be 10 cm, right? So if this is 10, so well, you can't even form the gutter because the length of this, the base of this triangle is already going to be 10, so it's impossible for you to form the gutter at all. And so this is impossible because x need to be something like greater than 0, of course. Well, it can be equal to 0, and it cannot be cannot be more than 5. And so we x equals to 10 is rejected, and so we have our answer here. Therefore v x is maximized when x is equal to 5 over 3 cm. And how do we show that? That is support our case. So we do the sign diagram. we pick a value that's less than 5 over 3 and sub it back into here. You will find that this is positive, 0 and now 5, and this will be negative. So then this is the shape of the curve at this part. So from the sign diagram, we verify that Vx, the volume, is maximized when x is equal to 5 over 3. So I hope you try this problem again or other similar problem, and all the best.